Hello, it's Mr. Potenski, and we are going to use our skills of combining like terms, so you should have watched that video already, to answer both problem 3 and 4 from the 8th grade review day 2. So we want to determine in number 3 whether the expressions are equivalent. So equivalent means equals. Are they equal? So we would set our expression 1 equal to our expression 2. And then we are going to use the skill of combining like terms. So we're looking for a term here. We have 1.25x, so we need another term that also has an x, or all of the terms specifically that have an x. And then we have a 4, which is a constant term, and a -3. So we can go through and combine those. 1.25 plus 0.75. So we have 5 quarters and 3 more quarters would give us 8 quarters, which we know is $2 or 2.00, and we can get rid of those zeros after the decimal and just put 2x. And then we have a +4 and a -3. So that can be, we can treat that as 4 minus 3, which is going to be a +1. So we find out that when we combine the like terms on the left side of the equal sign, we get 2x plus 1. And we discover that that is equal to what we were asked to know if they're equivalent. Since they are equivalent, so we know these are equivalent because we combined like terms. So that is our justification. So we combine like terms on the left-hand side, and that 2x plus 1 is equal to 2x plus 1. On to number 4, it says simplify this expression. So we're going to do this just a tad bit differently than what we have been doing. So another way to process through combining like terms is to gather all of our variables and do it that way. So I have a +4x, and we can do this because the commutative property of addition and subtraction. We can move and change where things are, so long as we treat this as a -9a. Okay, so we can't get rid of that subtraction. So we have 4a minus, or it would be a plus a -9a, but we can write it as -9a. And then we have a +8, because even though there's nothing written there, we know it's a positive, so +8 plus 6.2. And then this may be easier for you to negotiate with. So if we have a +4a and a -9a, we start at +4 on the number line and then go back 9. We're going to end up at -5. And then we keep that variable. And then we have +8 and 6.2. So we know that there's no tenths. We could put a 0.0 after that 8 if we wanted to, but we're going to get the 0.2 because they're both positive, and 8 and 6 is 14. So we should have gotten -5a plus 14.2 as our answer for number 4.